All right, so today we're jumping into what is basically a cosmic cold case. We're talking about a hunt that's been going on for decades, a search for a celestial ghost, a missing link in the universe's most extreme family. And let me tell you, the story of how it was finally found is just a fantastic piece of cosmic detective work.
So the whole mystery really boils down to this one question of scale. We know for a fact that we have these, smaller black holes that are born when giant stars collapse. And then we have the supermassive behemoths that sit at the heart of pretty much every galaxy. But how do you get from one to the other? There's this enormous gap right in the middle. It's a huge piece of the puzzle that's just been missing.
And right here, you can see that gap laid out plain as day. On the one hand, you've got your stellar mass black holes, maybe 100 times the mass of our sun. Found them, check. On the other end of the spectrum, the supermassive ones. We're talking hundreds of thousands, even billions of suns. Found those too, check. But right there in the middle, that's our ghost, the intermediate mass black hole, or IMBH. And finding one has been, well, just ridiculously hard. Until now. To find this cosmic ghost, our celestial detectives needed the perfect hiding spot. And they zeroed in on a prime suspect, a place called Omega Centauri. It's the biggest, most massive star cluster that orbits our very own Milky Way. So, what is a globular cluster? Well, think of it like a giant, glittering city of stars. It's this ancient, incredibly dense ball of maybe 1,000,000 stars, all crammed together by gravity. That density makes it the perfect hunting ground for a medium-sized black hole. But Omega Centauri, it's not just any old cluster. And here's the twist. This is the secret identity of our crime scene. Omega Centauri isn't a cluster that was born this way. Nope. It's actually the leftover core, the nucleus, of a small galaxy that our Milky Way ate a long, long time ago. And what that means is its central black hole would be sort of frozen in time, unable to grow any bigger, making it a perfectly preserved specimen of that missing link from way back in the early universe. Okay, so we've got the motive, we've got the location. You'd think, great, let's go find it. But not so fast. Finding the suspect turned out to be almost impossible. For decades, astronomers scoured Omega Centauri, but the black hole, it stayed a ghost. It just left no trace. And this really gets to the heart of the problem. A black hole that's thousands of times the mass of the sun, well, it should be messy. It should be gobbling up gas and stars, and that should produce all kinds of bright X-ray and radio signals. But when astronomers pointed their telescopes at the center of Omega Centauri, they got nothing. Just cosmic silence. So why the silence? Well, it turns out our black hole is being starved by what you can only describe as a cosmic hurricane. You got all these massive stars packed in at the center, and they're all blasting out these really powerful stellar winds. These winds smash into each other at insane speeds, creating this superheated, turbulent chaos that just violently blasts almost all of the gas right out of the cluster's core. The end result? Well, let's just say the black hole is on a starvation diet. Only about 1/100,000th of the gas that's even available ever gets anywhere close to it. I mean, that is a tiny, tiny fraction. So what does this all mean? Well, with basically no gas to eat, the black hole can't create those bright X-ray or radio signals that are its usual calling cards. It left no fingerprints at the scene of the crime. All the traditional methods for finding a black hole completely failed, which forced the research team to stop thinking like astronomers and start thinking more like detectives looking for indirect clues. And this is where the breakthrough happened. After decades of searching for a ghost, the astronomers just completely changed their tactics. They decided to stop looking for the black hole itself, and instead, they started looking for the chaos it was creating. And believe me, this was a long game. We're talking about a cosmic stakeout on an absolutely epic scale. The team used over 20 years of data from the Hubble Space Telescope, building up this massive catalog of the positions and movements of 1.4 million stars right in Omega Centauri's core. The new strategy was so simple, but just brilliant. They realized, okay, forget trying to see the black hole. We can't. So instead, they looked for its influence. It's like how you can't see the wind itself, but you can absolutely see the leaves it's blowing around. They started looking for stars that were being whipped around by some invisible, incredibly massive object right at the heart of the cluster. And that is exactly what they found. Buried deep in all that data, they found 7 stars, right near the center, moving at just incredible speeds. They were moving so fast that they should have been flung completely out of the cluster ages ago. The only possible way they could still be there is if something unimaginably massive was holding onto them with an iron-tight gravitational grip. The research team themselves put it perfectly. They called it the proverbial smoking gun. They hadn't seen the ghost, but they'd found the victims caught in its invisible web. So, with this smoking gun evidence finally in hand, the team could close the case and put a number on their cosmic suspect. By tracking the orbits of those 7 super speedy stars, the astronomers could calculate the mass of the thing they were orbiting. And the number they came up with was at least 8,200 times the mass of our own sun. Now, an object that massive, that compact, and yet totally invisible, well, it could only be one thing. And there it is. The verdict was in. The mass puts it squarely in the intermediate mass black hole category. The missing link was officially no longer missing. The cosmic cold case was closed.
And this is why this discovery is so cool. It used a totally different playbook. See, most black holes, we find them by seeing the light from the hot gas they're eating, the usual way. But this one was found by painstakingly tracking the subtle dance of stars around a point of pure invisible gravity.
So at the end of the day, why does this all matter? Well, finding this IMBH isn't just about ticking a rare object off a list. It's a critical piece of evidence. It helps us understand how the universe builds its giants. It really suggests that the supermassive black holes we see today might have grown by swallowing up smaller black holes, just like this one, over billions of years. It fills in that gap. And that leaves us with this one last, really tantalizing thought. This black hole was found hiding in one of the most well-studied objects in our sky. It really makes you wonder, doesn't it? With this new detective method in our back pocket, how many other cosmic ghosts are out there, quietly shaping their galaxies, just waiting to be found?